Alright, here's lesson 3-2. Curve sketching with extreme points, turning points, and inflection points. We're going to do pre-calculus and calculus, put it together, and the whole lesson's on graphing. My face is in the way. These are the things we're going to look for. The domain to be able to factor and remove, that creates a hole. What doesn't remove creates a vertical asymptote. Intercepts, end behavior, checking for symmetry. Finding increasing and decreasing, using number lines, concavity, and then graphing it. So let's do this together. Start one step at a time. Look at number one. Here I am. I'm floating in the middle now. I got to put myself back here. All right. So one step at a time. Number one, the domain comes from the denominator. So if I'm going to do that properly, I should factor it. So just above it, I have a little bit of room. I'm going to factor it. See if it focuses in. What two numbers multiply to 1 and add to -2 is -1 and -1. So I'm going to write it as -1 squared. So when I look at the denominator, x cannot equal +1 because that would make it 0 in the denominator. There's nothing that reduces down. So nothing is removable, so that 1 creates a vertical asymptote, and that means there's no holes because nothing's removable. The X-intercept comes from the numerator. So what makes the numerator 0? So add 2 and divide by 3. It's 2/3. Now I'm going to say the word odd and the word even. Now this has to do with the exponent. So you don't see the exponent here, but the exponent you don't see here is 1. It's odd, so it crosses. Here you can see the exponent. It's even. An even vertical asymptote. The behavior, both sides of the asymptote go in the same direction. So they both go to infinity or negative infinity. To find the y-intercept, plug in 0 for x, and you get -2/1, which is -2. The end behavior, I'm going to write as a line. It's the power term over the power term. So when the bottom is more powerful, the end behavior is 0. Symmetry, we can find symmetry if we plug in 1 and plug in -1. So if I plug in +1, I get, well, 1 won't work, but if I did 2 or -2, this one doesn't have symmetry. And part of the reason is that the exponents are off. One's odd, one's even. So there's no symmetry here. These have to do with turning points and the point of inflection. So for the derivative, we're going to do a number line for the first derivative. The critical numbers, look at the numerator. What makes it 0? So subtract 1 and divide by -3. So that's +1/3. And then the other number that we care about is +1. Now +1 is not a turning point because it's an asymptote, but it creates an interval of increasing or decreasing. So into the derivative, I'm going to plug in like 0, and I get a negative answer. Again, if I understand the odd exponents here, the signs are going to change as they go across because they all have odd exponents. And remember, this is an asymptote. So there is a turning point, and at 1/3 is a minimum. To find the y-coordinate, plug 1/3 in here. I'll do that for you. And it's -9/4, which is -2.25. Just to have a sense of it. There's no maximum. And there's no symmetry. The point of inflection comes from the second derivative. So look at the second derivative. Look at the numerator. What makes it 0? I'm going to do another number line here. So if you take the numerator equal to 0 and solve it, 0 is a critical number. And again, +1. What makes it undefined is critical too, but it's not going to be a point of inflection because it's an asymptote. Plug in a negative number. And again, notice the odd exponent compared to an even exponent. So if you plug in a negative number, it's a negative divided by a positive, which is negative. At 0, the sign changes. But at +1, the sign stays the same because of the even exponent. That means that 0 is a point of inflection. And if you plug in 0, you get the answer -2. That's the y-intercept. So the y-intercept is a point of inflection. All right, now we get to graph it. So start with 0, -2. We also have a point of 2/3. Here, let me change colors here so you can see it. That didn't help, did it? What else do we have? 1/3 and -2.25. Just a little bit lower there. So that's the minimum. And then we have asymptotes. So 0 is an asymptote. That's the end behavior. So it doesn't bother if it crosses over it. It's the ends. The vertical asymptote is at 1. And then away we go. So I know the end behavior is 0. I see these points, and so I look first. It's decreasing, and it's concave down. So we have the end behavior. It's decreasing and concave down to there. After 0, it's concave up, but we have a turning point here. So it's concave up, and it has a low point there, so we curve it, a smile, and then it turns and goes up. Now, we have an even asymptote, so that means both ends are going up then, and then it turns to the end behavior. And you graphed it. Let's try it again. Number 2. Domain. Look at the denominator. This one's if I look really carefully, no matter what number I put in for x, if you square it and add 2, it will always be positive and never be 0. So the domain is actually all real numbers. And because it's all real numbers, there are no vertical asymptotes and there's no holes. To find the x-intercept, you look at the numerator, equal to 0, and it has an odd exponent. The y-intercept, you plug in 0, and I'm left with 1 over root 2. No, you plug in 0, and you get 0 divided by whatever, which is 0. If I look at the end behavior, power term over power term, it would end up being x over... Now the square root of x squared could be positive or negative x. Could give you x squared. If I reduce it down, you get positive or negative 1. So in one direction it's positive 1, and in the other direction it's negative 1. Sometimes it's nice to even put it on our graph when we see it. So the right end behavior is positive 1, and the left end behavior is negative 1, and we have a point at 0, 0. Fill it in as we go along. Symmetry. If I plug in positive 1, I get 1 over the square root of 3. If I plug in negative 1, I get negative 1 over the square root of 3. So that means this is an odd symmetry. So whatever happens in the top right will match on the bottom left, or with the origin, you could say. Maximums and minimums come from the first derivative. Look at the numerator. There's nothing that makes it 0. So we have no maximums or minimums because we have no critical numbers. And then if I look at the second derivative, 0. So let me make sure that I understand. So for the first derivative then, no matter what number I put into the first derivative, it will always be positive, so it's only increasing. And then the second derivative, the only critical number is 0. If I put in a negative number, it's going to be positive, and if I put in a positive number, the answer is negative. So this tells me concavity. So there's a point of inflection at 0, and if you plug in 0, the answer is 0. So this is a point of inflection. So now we need to draw it. So this is increasing and concave up with the end behavior. So there's end behavior, concave up, and then it changes concavity, but continues to rise with the end behavior, and you have your graph. And that's it. Is that it? Oh, there you go. Mr. G Math. Now we'll do our assignment together. Till next time.